two curves y equal to mod of x square minus 1 and y equal to mod of x square minus 3 are given. We need to find the acute angle at their point of intersections. So it's better first we'll go to drawing the graphs of the given functions. Let's consider the two functions and first express them piecewise. Y equal to mod of x square minus 1 will change its character at plus 1 and minus 1. So this would be defined as x square minus 1 if either x is less than minus 1 or x is greater than plus 1, and otherwise if the x value lies between minus 1 and plus 1, then the graph is 1 minus x square. So let's plot the graph of the first function now. At minus 1 there is a change of nature and at plus 1 there is a change of nature. When x lies between minus 1 to plus 1, the graph is y equal to 1 minus x square. So it's a parabola open downwards. Where will it cut y-axis? When we put x equal to 0 here, y will become 1. So it will be up to 1 and then coming down up to plus 1. Right? Now, when x is more than 1 or when x is less than minus 1, the graph is y equal to x square minus 1. So it's a parabola which is opened upwards. So this will be the graph of y equal to mod of x square minus 1. Let's proceed with the same way to identify the second function. Y is modulus of x square minus 3. Yes, this will change its character at minus root 3 and plus root 3. So how do we define this function? It is x square minus 3 if the value of x is less than minus root 3 or x is greater than plus root 3, and similarly between minus root 3 and root 3 the function is 3 minus x square. How will be the graph of this function when we put it on the same axis which we have drawn the previous graph? Yes, this will change the nature at minus root 3 and plus root 3. So between minus root 3 to plus root 3, if you look at, the graph is y equal to 3 minus x square, a parabola open downwards. Where will this cut y-axis? When we put x equal to 0, y becomes 3. So this will cut y-axis at 3 and open downwards. And below minus root 3 and above plus root 3, the graph is y equal to x square minus 3, which is a parabola open upwards, and on the left side of root 3 also it's a parabola open upwards. So this is the graph of y equal to mod of x square minus 3. Now clearly what is the requirement? At their point of intersection we need the angle between the two curves. So the point of intersections being symmetric in both the quadrants 1 and 3, that is images with respect to y-axis. Can we identify the angle at A and B, right? But angle at A would be same as that of the angle at B. So let's proceed to find the angle at the point A. How will be the point A? At this point, the graph of y equal to mod of x square minus 3 is open downwards, and the graph of y equal to mod of x square minus 1 is open upwards. So at the point A, what are the two curves which are meeting? 3 minus x square, that is the graph of y equal to 3 minus x square, is meeting the graph of x square minus 1, which is open upwards. So that gives us x as root 2, and similarly we can find the y coordinate as 1. So what is the point A coordinates? A coordinates are root 2 comma 1. Once we have the coordinates of A, finding the angle between the two curves is quite simple. How do we proceed to find the curve? Angle between the two curves. For the first curve y equal to x square minus 1, the value of dy by dx is 2x. So what can you say about slope of tangent at this point to the first curve? It is 2x measured at A, that is 2 into x coordinate is root 2, so that is 2 root 2. So we got the slope of the tangent to the first curve. Similarly for the second curve y equal to 3 minus x square, the value of dy by dx happens to be minus 2x. For this, when we differentiate, what is slope of the tangent to the second curve? M2 would be minus 2x measured at the same point A, which is minus 2 root 2. Now we have the tangents of both the curves. Then we know that angle between tangent curves is equal to the angle between the tangents, for which we know the slopes of both the lines. So how much is this? This is tan inverse of mod of m1 minus m2 by 1 plus m1 into m2. That is tan inverse of m1 minus m2, 2 root 2 minus of minus plus 2 root 2, that is 4 root 2 by 1 plus 2 root 2 into minus 2 root 2, that would be minus 8. So this is simply tan inverse of 4 root 2 by 7. So if this angle is assumed to be theta, by this calculation we got tan theta value. But what is the requirement? We need cos theta value. So tan theta, when expressed in terms of cos theta, it would be cos inverse of 7 by 9, right? So what is cos theta value? The value of cos theta which is required is 7 by 9, present at option A with the choices.